In this talk, we're going to present our recent work, a unified reinforcement learning approach for autonomic cloud management. Cloud computing, unlocked by the virtualization technology, is becoming an increasingly important IT paradigm. Since Internet services have time-varying resource demands, running these applications in the cloud requires on-demand dynamic VM resource reconfiguration to meet the actual demands of Internet services. In response to the dynamic capacity of virtual machines, applications running within the virtual machine should also be dynamically tuned to attain the optimal performance. In this work, we develop a unified reinforcement learning-based approach for automated and coordinated tuning of both VM resources and application parameters. In this slide, we show three provisioning scenarios. Over-provisioning allocates resources for the peak demand and leads to significant resource waste. In contrast, under-provisioning increases the resource utilization but incurs application service level violations. Dynamic provisioning improves both utilization and application performance, but requires some form of automation to translate the amount of resources allocated to the high-level performance. However, dynamic VM resource provisioning requires online tuning of application configurations to attain the optimal performance. We show the optimal parameter settings of TBCW in VMs with different capacities. Y-axis represents the average request response time. The lower, the better. The figure shows that the best application configuration in one VM is only suboptimal in a VM with a different capacity. This observation calls for the coordinated tuning of both VM capacity and application configuration. The automation of the reconfiguration process requires mathematical models that translate high-level performance to the desired resource and parameter settings. However, the modeling is hard due to the time-varying application demands, the performance interference in the cloud, and the heterogeneous cloud hardware. Therefore, the model should be robust to the complex cloud environment and also adaptive to the application and the cloud dynamics. In this work, we find reinforcement learning is a good method for automating the auto-configuration process. Reinforcement learning is a process of learning by interactions. It emulates the way animals learn about the external world with trial and error interactions. Reinforcement learning is model-free and adaptive to the environmental changes. It uses a high-level goal to guide the exploration of the environment. After each interaction, a reward will be returned to the learning agent. The learning objective is to derive an optimal policy that maximizes the cumulative rewards. The reconfiguration of VM resources and application parameters fits within the agent environment framework, where an auto-configuration agent tries different configuration settings and looks for configurations that maximizes application performance. We formulate the auto-configuration of VM resources and application parameters as a reinforcement learning task. Specifically, the goal is to maximize the application throughput and minimize response time. Each state is defined on a vector of VM resource configuration and the application parameter settings. The auto-configuration agent traverses the state by increasing or decreasing one parameter at a time. The agent will finally stop at the state with the best performance. We performed experiments to evaluate the effectiveness of the unified reinforcement learning-based approach. The figure plots the response time of TBCW and the three different policies: the default application configuration, a manual tuning process, and the reinforcement learning-based approach. We injected workload changes and the VM capacity changes into the test. Results show that the unified reinforcement learning-based approach achieved a better response time than other approaches. More importantly, it is autonomous and can drive the system to the optimal or near-optimal configurations in a few steps. In conclusion, URL is effective in application tuning and VM capacity management, even in the presence of workload and cloud dynamics.